In today's class, we'll study these points to study the next problems. The constant function f of x is equals to k is continuous at every real number. The identity function f of x is equals to x is also continuous at every real number. Even every polynomial function is also continuous. But the greatest integer function, it is not continuous everywhere. It is discontinuous at every integral point. For example, at x is equals to -1, the greatest integer function is discontinuous because -1 is an integral point, nothing but integer. So what this implies, at every integers, the greatest integer function is discontinuous, whereas at decimal points, it is continuous. For example, 1.1, 0.1, 2.1, at all these points, the greatest integer function is continuous. The modulus function is continuous at every real number. So we have to keep all these points in the mind to study the next problems. Next, algebra of functions. If you have two functions f and g which are continuous, then f plus g is also continuous at c, f minus g is also continuous at c, f into g is also continuous at c, f by g provided g of c is not equals to 0 is also continuous at c. Nothing but if you consider two functions f and g which are continuous, then if you add those functions, then it will be continuous f minus g, nothing but if you find the difference, or if you find any function, if f is continuous and g is continuous, then f minus g will be also continuous. So from this, we know that every polynomial function is continuous. What is rational function? One polynomial divided by another. So if both f and g are continuous, f by g will be also continuous. Nothing but every rational function is continuous. Even every trigonometric function is also continuous, like sine, cos, tan, cot, secant, cosecant. All these functions are continuous functions at some particular points. If f and g are continuous functions, then f composition g is also continuous. So we'll use all these points to study the next problems. First problem, f of x is equals to x square minus sin x plus 5. So we can write this function as f of x is equals to, so we'll consider x square plus 5 minus sin x. So we can clearly see that x square plus 5 is a polynomial function, whereas sin x is a trigonometric function. So if I consider this as f and this as g, so it looks like f minus g. So we know that every polynomial function is continuous and trigonometric functions are continuous. So obviously f minus g will be continuous. Nothing but the given function f of x is equals to x square minus sin x plus 5 is a continuous function. We'll consider the next problem. The second one, f of x is equals to sin x plus cos x. We can clearly see sin x, which is a trigonometric function which is continuous. Even cos x is also continuous. If you consider sin x as f and cos x as g, so if f is continuous and g is continuous, then f plus g will be also continuous function. From this we can say even the second function f of x is equals to sin x plus cos x is also continuous function. We'll consider the next example. Third one, f of x is equals to sin x into cos x. Similarly, so we'll call sin x as function f and cos x as function g. So if f is continuous and g is continuous, then f into g is also continuous function. So clearly even the third function is continuous. We'll consider the next one. F of x is equals to cos of x square. You can clearly see it is a composition of two functions, cos x and x square. So if I consider cos x, some h of x as cos x and g of x as x square. So h composition g is equals to cos of x square. So from the composite function note, we can clearly see that if h is continuous and g is continuous, then h composition g will be also continuous. So from this, even cos of x square is also continuous function. Next question, f of x is equals to modulus of cos x. Again, it is a combination or composition of two functions. One is mod x and another one is cos x. We know that mod x is a continuous function. Even the trigonometric function is continuous function. Therefore, the composition of this two will be also continuous. So, from that again, the given function f of x is equals to mod cos x is also a continuous function. Next one, f of x is equals to sine mod x. So here again it is a composition of two functions. One is sine x, another one is mod x. We know that sine x is a continuous function, even mod x is a continuous function. Therefore the composition of these two, that is sine mod x, is also a continuous function. So here we have a function mod x and mod of x plus 1. So even mod x is a continuous function and mod x plus 1 is a continuous function. So it looks like f minus g. F is a continuous function, even g is also a continuous function. What that implies? F minus g is also a continuous function. So now by using the definition of continuous function, we'll find the values of k if the given function is continuous. So find the value of k so that the function is continuous at the indicated points. So they have given a function which is continuous. Using the concept of continuous function, we have to find the value of k. So let us do that. So let us consider an example. F of x is equals to kx square if x is less than or equals to 2. 3 if x is greater than 2 at x is equals to 2. So they have given at the point x is equals to 2, the given function is continuous. So let us write down that given f is continuous function at x is equals to 2. According to definition of continuity, LHL will be equals to RHL, that is equals to f of given point. So what is LHL? Left hand limit. So we know how to find this limit as x tends to 2 minus f of x, that is equals to what is RHL? Right hand limit. So limit as x tends to 2 plus f of x is equals to f of 2. So limit as x tends to 2 minus. So 2 minus in the sense we have to consider f of x which is less than 2. So for x less than 2, the function is kx square. So I'll consider that limit as x tends to 2 plus. So 2 plus means greater than 2. X greater than 2, the function is 3. I'll consider that as well. That is equals to f of 2 in the sense at 2, what is f? So at 2, the given function is kx square. So f of x is kx square at 2. Now we need f of 2. That is, wherever x is there, I have to substitute 2. K into 2 square, which is 4. Nothing but we are getting 4k. I'll substitute that as well. So now we know how to find the limit. Wherever x is there, just I have to substitute 2. So k into 2 square, that is equals to, we know that limit of a constant function is constant itself. So that is equals to 4k. 2 square is 4. 4 into k is 4k. That is equals to 3, which is equals to 4k. So we can consider any of these two because 4k is equals to 4k. So that implies 4k is equals to 3. So we'll get the k value as 3 divided by 4. That is the required k value. Second example, f of x is equals to kx plus 1 if x is less than or equals to pi, cos x if x is greater than pi, at x is equals to pi. Nothing but the given function is continuous at x is equals to pi and we have to find the value of k. So let us do that. Given f is continuous function at x is equals to pi. So since it is continuous, by definition of continuity, we can write LHL is equals to RHL is equals to f of given point, that is pi. So LHL in the sense limit as x tends to pi minus f of x, that is equals to limit as x tends to pi plus f of x, which is RHL, and that is equals to f of pi. So limit as x tends to pi minus in the sense less than pi function we have to consider, which is kx plus 1. I'll write down that. That is equals to limit as x tends to pi plus. So pi plus in the sense greater than pi. X greater than pi, the function is cos x. That is equals to f of pi we have to find. F of pi means we have to consider the function which is equals to pi. So x is equals to pi, the function is kx plus 1. We need to find f of pi. So wherever x is there, I have to substitute pi. So k into pi, that is pi k plus 1 will get. So I'll substitute that. Now let us find the limit. So if I substitute pi over here, I'll get pi k plus 1, that is equals to, so wherever x is there, I'll put pi, that is cos pi, which is equals to pi k plus 1. Since these two are same values, we will get pi k plus 1 is equals to cos pi. So cos pi in the sense cos 180 degree, which is minus 1. So pi k plus 1 is equals to minus 1. So we need the k value. So I'll keep k value here itself. I'll send the remaining constant toward other side. So this plus 1 will become minus 1, which is minus 2. So we are getting pi k is equals to minus 2. But we need to find the k value. So this implies k is equals to minus 2 divided by pi. So we have got the result. Next example, f of x is equals to kx plus 1 if x is less than or equals to 5, 3x minus 5 if x is greater than 5 at x is equals to 5. So they have given this function is continuous at x is equals to 5. So we have to find the k value by using the concept of continuity. So let us write down that. Given f is continuous at x is equals to 5. So by the definition of continuous function, we can write LHL is equals to RHL is equals to f of given point. So LHL means limit as x tends to 5 minus f of x, that is equals to limit as x tends to 5 plus f of x, that is equals to f of 5. So limit as x tends to 5 minus in the sense x less than 5 function we have to consider. So at x less than 5 the function is kx plus 1, that is equals to limit as x tends to 5 plus. So 5 plus in the sense greater than 5, the function is 3x minus 5, that is equals to f of 5 we have to find. So at x is equals to 5 the function is kx plus 1. So f of x is kx plus 1. We have to find f of 5. So f of 5 means wherever x is there I have to substitute 5. So I'll be getting 5k plus 1. So I'll substitute here 5k plus 1. Now let us find the limit. So 5k plus 1 is equals to, if I substitute 5 here, 3 into 5 minus 5, that is equals to 5k plus 1. So since both are same values, we can write 5k plus 1 is equals to 3 5s of 15 minus 5. So 5k plus 1 is equals to 15 minus 5 is 10. So 5k is equals to 10 minus 1, that is 9. We need k value, that is equals to 9 by 5. We have got the required solution. Next example, f of x is equals to k cos x divided by pi minus 2x if x is not equals to pi by 2 and 3 if x is equals to pi by 2 at x is equals to pi by 2. So they have given this function is continuous at x is equals to pi by 2. Till now the function was given as x is less than or equals to greater than. So but here you can clearly see x is not equals to pi by 2 and x is equals to pi by 2. These are the things which they have given. So let us see what can be used. So given f is continuous at x is equals to pi by 2. If it was less than greater than, we would have used the definition LHL is equals to RHL is equals to f of pi by 2. But here they have not given that. So we'll use this definition. So this implies limit as x tends to pi by 2 f of x is equals to f of pi by 2. Nothing but the limit will exist and it will be equals to f of given point. So this definition we'll use here. Limit as x tends to pi by 2 f of x is equals to f of pi by 2 means we have to find f of x value at x is equals to pi by 2. So at x is equals to pi by 2 f of x is 3. So f of pi by 2 will be also equals to 3. So call it as equation 1. So we'll consider the LHS. So whatever, if you see in this equation, LHS is this one. We'll consider the LHS separately and we'll find the solution. Then we'll substitute back in equation 1. So LHS is limit as x tends to pi by 2. So at x is equals to pi by 2, the value is 3. X tends to pi by 2 means it is either less than pi by 2 or greater than pi by 2. The value is k cos x divided by pi minus 2x. That function I'll substitute here. K cos x divided by pi minus 2x. So let us substitute the value and find the limit. So if I substitute pi by 2 here, so we'll be getting cos k into cos pi by 2, which is cos 90 is 0 divided by pi minus 2 into pi by 2 is pi. So we are getting 0 by 0 form. Whenever we get 0 by 0 form, we have to do some substitutions to get the value. So for that I'll make a substitution. Let the denominator pi minus 2x be some t. So from this we can clearly solve for x, which will be pi by 2 minus t by 2. Now since we are changing x into t form, x tends to should also change it as t tends to. So as x tends to pi by 2, nothing but if I substitute pi by 2 over here, 2 will get cancelled, pi minus pi will be equals to 0. So as x tends to pi by 2, the t will tend to 0. So our LHS becomes limit as x tends to, instead of x we have to change it to t. So t tends to 0, k into cos of, instead of x we have to write pi by 2 minus t by 2 whole divided by pi minus 2x is t. So we have converted x, the function of x, into the t, function of t. Now let us find the limit. So here limit as t tends to 0, k into, so it is looking like cos of 90 minus theta. Cos of 90 minus theta is sin theta. So sin, in the place of theta we have t by 2. I am substituting that, all divided by t. So that is equals to, we have a theorem in first view, that is limit as x tends to 0, sin x divided by x is equals to 1. So to apply this we have to convert the angle. So whatever the angle we have t by 2, here also it should be t by 2. For that what I'll do is I'll multiply and divide 2. Now if I take out this k out, so limit as t tends to 0, sin t by 2 divided by t by 2, remaining 1 by 2 I'll write over here. Now we can apply this formula for this function, which is 1. So k into 1 into 1 by 2. So that is equals to k by 2. Now substitute this value in equation 1. So equation 1 implies this value is k by 2. I'll write over here, that is equals to 3. So k is equals to 2 3s are 6. That is the required k value. Let us consider the next example. Find the values of a and b such that the function defined by f of x is equals to 5 if x is less than or equals to 2, ax plus b if 2 is less than x less than 10, 21 if x is greater than or equals to 10 is a continuous function. Nothing but they have given a function at 2 points, that is x is equals to 2 and x is equals to 10. At both the points it is a continuous function. So let us find the value of a and b. So it is clearly given that it is a continuous function. First we'll consider at a point x is equals to 2. At x is equals to 2, f of x is given as 5 if x is less than or equals to 2, ax plus b if x is greater than 2. So it is a continuous function, nothing but at x is equals to 2 also it is a continuous function. So we'll write that given f is continuous at x is equals to 2. If it is continuous at x is equals to 2, then by the definition left hand limit, that is LHL is equals to RHL, which is equals to f of 2. So LHL is limit as x tends to 2 minus f of x, that is equals to limit as x tends to 2 plus f of x, that is equals to at 2 what is the function? It is 5. So f of 2 is 5. So limit as x tends to 2 minus means less than 2. At x less than 2 the function is 5. Limit as x tends to 2 plus. 2 plus means greater than 2. So at greater than 2, x greater than 2 the function is ax plus b, that is equals to 5. Now let us find the limit. So limit of constant is constant itself, that is equals to, here wherever x is there I have to substitute 2. So I'll be getting 2a plus b, that is equals to 5. So from this we can clearly write 2a plus b is equals to 5. So call it as equation 1. Now at x is equals to 10, the given function is, so we can clearly see over here at x is equals to 10, they have given a function ax plus b if x is less than 10 and 21 if x is greater than or equals to 10. So they have given it is a continuous function. So given f is continuous at x is equals to 10. So according to continuity definition, LHL is equals to RHL, that is equals to f of 10. So LHL means limit as x tends to 10 minus f of x. RHL means limit as x tends to 10 plus f of x, that is equals to f of 10 means at 10 what is the function, which is 21. We'll write down that. Now limit as x tends to 10 minus in the sense x less than 10. What is the function? Ax plus b. Limit as x tends to 10 plus means greater than 10. The function is 21, that is equals to 21. Now let us substitute the value 10. We'll be getting a into 10 is 10a plus b, that is equals to limit of constant is constant itself, that is equals to 21. So we are getting 10a plus b is equals to 21. Call it as equation 2. So we have to find the value of a and b, that is two variables. We have to find the value of two variables and we have two equations. If you solve, you will get the answer. Let us do that. We have to find the value of a and b. We have two equations. So let us solve that. I'll change the signs. So b and b will get cancelled. 2a minus 10a is minus 8a, that is equals to 5 minus 21 is minus 16. So a is equals to minus 16 by minus 8. So minus minus cancels, 8 ones are 8 twos are. So I have got a is equals to 2. So put this value in equation 1. So equation 1 implies 2a plus b is equals to 5. So let us substitute the value of a. 2 into a is 2 plus b is equals to 5. 2 2s are 4 plus b is equals to 5. If I solve for b, I'll be getting 1. That is the required solution. The value of a is 2 and the value of b is 1.